Today we're going to be talking about powers of I. There are a couple of things we need to remember first. First is that I is defined to be the square root of -1, and there are a couple of exponent rules that we're going to be using today. If we multiply the same base, we add the exponents. If we take a power to a power, we multiply the exponents. In both cases, I'm going to be using these in the opposite direction. I'm going to start with an exponent that I want to split up something like this, or I'll start with an exponent like this that I want to split up like this. Let's first remember all of our powers of I. I'm just going to simply write I is equal to I. When I go to I squared, I can write this as the square root of -1 quantity squared. The square root and the square will eliminate each other or cancel to get -1. When I take I cubed, I can write I cubed as I times I squared. That's using this property over here, 1 plus 2 equals 3. But remember that I squared equals -1. This is just I times -1, which is negative I. I to the fourth then is going to be I squared times I squared. Well, this is -1 times -1. That better equal 1. I to the fifth is I times I to the fourth. Well, I just figured out that I to the fourth equals 1. This is I times 1. That equals I. I to the sixth is I squared times I to the fourth. This is -1. This -1 here and +1 here. -1 times +1 equals -1. And there is a pattern here. I, -1, -I, 1, I, -1, continuing on would be -I and 1. And this pattern will repeat for an infinite number of powers of I. Let's try a couple of examples for an easy way to simplify powers of I. Let's start with I to the 33rd power. What I'm interested in here is whether or not this power is even or odd, because if it's odd, the first thing I want to do is factor an I out of it. This is I times I to the 32nd power. Okay, and again, 1 plus 32 equals 33, so I'm using this first exponent rule here. Now I'm going to use the second exponent rule. First thing I'm going to do is carry along the multiply by I. I'm going to split this up. I want to write it as I squared to a power. And so I'm going to divide this by 2, and I get 16. 2 times 16 equals 32. That's my second power exponent rule. Okay, now I'm going to write my I squared as -1. This is I times -1 to the 16th power, and -1 to any even power is always going to equal 1. So this is just I times 1, which equals I, simplifies to I. Now let's try I to the 127th power. Again, this is an odd power, so the first thing I'm going to do is factor out an I and write this as I to the 126th power. Okay, now that I've got my even exponent here, I'll carry along the multiply by I. I'm going to write this as I squared and dividing, and I need to take it to a power, and that power is going to be 63 because 2 times 63 is 126. Okay, now I'm going to write I squared as -1 to the 63rd power. And this is -1 to any odd power is still going to be -1. So this simplifies to -I. If I'm doing I to an even power, it becomes even easier because I already have an even power. I don't have to factor an I out first. I'm going to write this as I squared. 54 divided by 2 is 27. I can write this as -1 to the 27th power. -1 to an odd power is -1. And that's an easy way to simplify powers of I.